Yeah, find the first and last position of the element in a sorted array. Ah, pretty simple, isn't it? Why is it hard? Sorry, why is it medium? Given an array of integers sorted in non-decreasing order, find the starting and ending position of the given target value. If target is not found in the array, return -1. You must write, oh, that's why it's medium. That's why it's medium. Hmm. Yeah, so uh, there is a binary search algorithm that I need to use, and how do I? So okay, so let's visualize this. Otherwise, we'll not able to solve ever. Okay, so let me go through my checklist first. The input is sorted int array, and output is list of indexes, right? And if target not found, then -1 -1. Okay, cool. And also as input we have target. Okay, that makes sense. Great. Now going further, uh, let's see about the size. So size of the array, is it going to be an empty? Can it be an empty? Yes, it can be an empty. So size can be from 0 to 10 raised to 5, which is around 100 million, right? No, sorry. 10 raised to 5 is how much? 100k. Yeah, 10 raised to 5. Got it. And what about the values? So values can be in the range of 10 raised to -9, so 1 billion to 10 raised to 9. Okay, so we can have that. This is the property sorted, so we can have duplicates. So we can have negative, we can have positive, we can have 0, we can have duplicates. Cool, makes sense. Now coming to my proper checklist, which is test slash edge cases. I'll go design code time space. So space complexity they have given us. We need to have like O of log n. Space will figure out test case, edge case, empty list, right? Empty list. In that case, this is the requirement. So let me write it down. If len of nums equal to 0, return -1. Okay, that's fine. Now let's take this example and try to figure out how we can do a binary search, right? So let's say this 0, 1, 2, 3, 4, 5. So uh, so we do index, right? Indexes plus and then divide by 2. So in this case we get this as a mid, right? And is mid equal to target? Target is what is target here? Target is 8 here. Okay, so is it equal to 8? No, it's not. Then we check two conditions in binary search. Is it less than or greater than? So is it less than 8? Yes, it is. So we increment the left index, so we go here, right? Now the question is, now in normal binary search we would return the index of this value, but the um, question remains in such a way that we have to figure out, is this the first index, and is this a last index? So how can we figure that out? uh hmm. Can I do a binary search recursively? Is it possible? because because the thing is, uh so let me tell you what I'm thinking. Let's say there was like multiple 8s here. Okay, so what I'm thinking is right now is, uh, if I get a 8, right? If it is not equal, then fine, we just go in both, in any direction. But once I find 8, right? Once I find 8, now there are two options for me here. From this 8, start iterating in this left direction, in right direction, and as soon as you don't find the equal to number, you just put left as that and right as that and return that. So it kind of becomes a linear search. But now what I'm thinking is, uh, let's say I found 8 here. Then what I will do is I will update left and right. Okay, and I will not stop my binary search. I will make it search in this direction again, and I will make it search in this direction again, and I will update left and right, something like this: min of already left and current index, right, and right is equal to max of right and current index. So that's what I'm thinking. But the only concern that I have right now is, how can I do it recursively? That's the only thing that I don't understand. Because in normal binary search, we either go in this direction or we either go in this direction. Yeah, so that's the only concern that I have. How can I do that? If I found it, then R is equal to I think I have to write a recursive binary search function. So let me try to write recursive binary. Let's make it small. Recursive binary, and it gets left and right values. Okay, and target it can take from here directly. So that's what is happening. Okay, understand. Now we have mid. Okay, so mid is equal to how it is calculated: left plus right minus left divided by 2. So left is 0, right is 5, 5 minus 0 is 2. 5 minus 0 is 5, divided by 2 is 2, so 0 plus 2. Yeah, so makes sense. This is just used to avoid any overflows. Now let's take two. There are three cases, right? So let's just take the first condition. Like it doesn't match, but it can go in either direction. Okay, so let's see. If nums of mid, right, is less than target, right, else pass. And let me write it as elif. And if nums of mid equal to target. Okay, so these are three possible conditions. Either it matches, otherwise the mid is less than target, or it is greater than target. And let's say the result is this -1, -1. Okay, so now we have one condition, this one. So nums of mid, let's say this is less than target, so target should be in this direction, so we have to increment the left. So we do I forgot the base condition. Okay, so we do left we do the recursive binary search on starting from mid, right, starting from mid plus 1. So now the left becomes mid plus 1 and the right remains same. So we'll do the recursive binary on this side of the section. Otherwise, if it is less than, let's say we are here and we are searching for target, so this is the mid, so mid -1 should be right and the left should remain the same. So left remains the same and the right changes to mid -1. And the base case will be like if um, right left is greater than right, and return, then just return. Yeah, that's it. And that's the base case. We don't do anything, then we calculate the mid. We go in left or right direction. And now the question becomes, if it is equal to mid, then I have to do two things, right? So result, let's see, so result, we have to update result now. So result of 0 is equal to min of result of 0 or mid, and update the right pointer is max of 1 or mid. So did you understand what I'm doing here? So let's say the first time when we come here, okay, so it will not work because min of this is going to be crap. So min of this will always remain -1. So somehow I have to change these values. Yeah, I think I can do that. This starting index can be the length and ending index can be -1, right? So basically what I'm doing is, let's say I come here first, it's a fourth index. So min of result of 0, which is like length of nums, and 4. So this will become 4, and this will remain, this will also become 4 because this is -4, and this is this is this -1 and this is 4, so max of that is 4. So basically in case there is only one element, then we should have same index for both of them, right? So that's the intention here. And next time we'll go in this direction and this direction both. So again we'll find somewhere 8. So at that time, let's say here I come here, then now the result is 4 and mid will be 3. So that should happen. So it should update. And when I come here, the result will be, let's say 4 and mid will be 8 or 9 something. So that will be updated. So that's the only logic here. I think I took a lot of time explaining that, and sorry about that. Now let's go in both directions. So now we have to do binary search in both directions. Yeah, and once it reaches this, it is going to return, it's going to return, it's gonna end somewhere. Right. Okay. And let's say what if we don't find a number, then this, if we return result directly, then it's not a good idea. So we have to check for that. So if result of 0 is equal to len of nums, which we by default set, right? Or I can just check for like result of 1 equal to -1. Why should I call this function? Because I already set -1, right? So if this -1 has not changed, that means we did not find the number. So in that case, return -1 -1, otherwise return the result. Let me try and see if there are any bugs. Output expected. Oh, okay, I did not call. This is the major problem that happens every time. Every time. Len of nums -1. Okay, so basically working fine so far. Let's check for these conditions. Okay, so all conditions are working. Empty, not found, found. Just in case, just in case, let me do this. Great. So I think we have the solution. We haven't used any extra space, but there is kind of a recursion here happening, right? Yeah, but again, it's gonna be at 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 most log n. Yeah. So let's say the array was sorted, okay, from 1 to 100, and you are looking from for -1. So in first case, you will remove the 50%. Then in same recursion, you will again recurse to remaining 50%. You will again recurse to remaining 50%, and you will come here, and then you will return, and then you will return. So if you count the recursion, the space used is log n, but if you don't count it, it's O of 1. But I'm not sure about the if it will work. Let's see. There could be any bug. Oh, great. It worked. So that is awesome. Thank you so much. Bye bye.